So I'll be talking on annotation processes. I assume some of you have at least idea what is annotation processing. If not, no worries, we'll cover that as well. And yeah, so we'll first start with introductions and then problems and what are the solutions we have, and we'll then go into in-depth things. So talking a bit about me, I'm Rajesh. I have around 7 years of experience, and I do work on as an Android developer. Okay, and apart from it, I do write technical contents. I host the live sessions, and as you can see, we host the meetups as well. Cool. Just give. Yeah. So what we are going to do is we are going to see the problem first, and then we'll jump into the solution. So my talk is a bit of a coding part as well. So I would expect, I just want to make it interactive. Okay, so we'll talk and we'll do these things. So what we see as a common pattern in Android development is we create an interfaces for, let's say, you have a repository class, okay, or a view model class. We create interfaces, we provide its implementation, and with whatever DI library you are using, for example, let's say Hilt. How many of you are using Hilt? Cool. So what about others? Coin or manual injections? Coin. Okay, coin वाले कम होंगे, तो we'll focus on it. ठीक है. So what you do is then you generate the binding codes via the Hilt library. Okay, so let's say you have interface like my repository, and then you have its implementation. My repository implementation, you inject construction and do this. And then what you do is we write the binding codes for each of these things, like modules and installing whatever components you want to install, abstract code, and then you have a bind function. So this code looks visible, right? I mean, it's visible to everyone, and it's familiar as well. Do we have anyone who don't know what this code does? So basically it just binds the Hilt interface with implementation. Now this works fine, and we write this code, no problems, no issues. But what if you have hundreds of the classes that you want to bind? Because in production applications you want just have 2 or 3 or 4 classes, right? You will have hundreds of the classes. So then it becomes this. Okay? Because you won't have a time, right? Because you won't have 3 दिन में भी ये खत्म नहीं होगा. Hundreds of class को manual code लिखने बैठोगे तो it's a too much hectic and laborious as well. As a developer, अपना goal क्या है कि we want to make it automated. Cool. So how do we do it? I mean, any ideas, any suggestions? How can we improve it? This manual writing thing? Anyone wants to share anything? Cool. Nice. Perfect audience. Okay. So what we are going to do is we are going to automate this entire process with annotation processing. Okay. So what is annotation processing? So annotation processing is basically you create your annotations and then you write the code that will generate another code for you. So basically what we are doing, we are not just writing the code. We will write a code that itself will write another code. Okay? And I assume and I believe all of you have used this annotation processing at some point of time. Let's say, for example, room ka example. Room has DAOs and entities and those things, right? Those are what? They are annotations. So when you add these annotations, room will generate some code for you. Retrofit mein le lo, you have @get, @post, @URLs. ठीक है. Hilt में ले लो @Android entry point, Android view models. ठीक है. तो at some point of time, all of us have dealt with annotation processing. It's just that we are using the processes created by someone else, right? अपन ने अपना नहीं किया. So what we are going to do today? We are going to create our own annotations and its processor as well. So first of all, what is annotation processing? You define annotations. You write a processor that will look into this. I mean, it will look at the source code at the compilation time, which classes or which methods or which properties are using these annotations. Then you will write whatever code you want to write, and then you will generate some source codes. Okay? So this is the steps that we are going to follow. annotation processing, we have two things in Kotlin, KAPT and KSP. Right? Anyone knows the name of a KAPT? What is the full form of a KAPT? Awesome, cool. So basically, why the KAPT? The origin is Java had these things called APT, Annotation Processing Tool. Right? So when the Kotlin was introduced, there was no annotation processors that can handle these annotations. So what the Kotlin team did is they created a sort of a wrapper. Okay, it's not a perfect definition, but consider it as they created a tool, Kotlin Annotation Processing Tool, similar to Java's APT, and they called it KAPT. Okay, what this tool does is जैसे कि room ने अपना annotation processor लिखा है, तो ये tool क्या करेगा? ये tool room को आपकी applications के source code में जितने भी annotations जहां पर भी लगे हुए हैं, वो information room को देगा, and based on these details, room will generate some sort of a code. Okay, अभी there is a new guy in the market called KSP. How many of you started using the KSP? One guy only? 2, 3, awesome. ठीक है, तो I assume बाकी के लोग using the KAPT. ठीक है. So the thing was why this new things KSP? तो KAPT जो था ना, that was creating the Java stubs for all the annotations. ठीक है, तो basically it was not a Kotlin native. ऐसा नहीं था कि ये Kotlin के लिए अच्छा खासा बना दिया, वो तो अपने पास टाइम नहीं था and solution नहीं था, तो KAPT बना दिया. But it was not a perfect solution. And Kotlin needed perfect solutions. So the Google and JetBrains came up with another annotation processing tool called KSP or Kotlin Symbol Processing. It's a more than annotation processing, but we'll use the KSP for this task only. Okay, so if you compare these two things, KAPT is slower because it needs to generate the Java stubs for every annotations. KSP is faster because it's Kotlin native, it understands everything about the Kotlin syntax, be it your suspending functions and coroutines and whatever the keywords you use. KAPT interop is limited, KSP provides the rich API, so you can create a whole lot of things with the KSPs. And KAPT is not a future proof because since we have a KSP, Kotlin की जो team है official JBT, तो उन्होंने they have said कि KAPT is in a maintenance mode. Okay, तो अभी there will be no new updates, no new improvements and fixes. What you should do is KSP is a recommended solution for annotation processing. तो अभी अपना custom बनाने की बात तो side में रखो, जो use करते हैं rooms and all these things, उसके लिए भी you should migrate to KSP. Okay, instead of using the KAPT. So in 2025, the state of a KSP is like this. ठीक है, तो what you should do is you should use KSP. Okay, because almost all the libraries, Hilt, Room, Retrofit, Glides, Coil, Moshi, whatever, they have support for the KSP. So you should use KSP instead of KAPT. So what we are going to do? Okay. So the first things we'll go is we'll define our custom annotations. This is the first step. The second step is we'll create symbol processors to scans and blah 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 and lot of theory. So let me just jump into the code. Just give me a sec. Cool. So as you can see, I have interface my repository which simply have functions do some things and then it has my repository IMPM. Okay, so each interface and implementation is better. And then what I am doing is I am creating this. I've created this Hilt bindings as you can see and I've shown in the PPT as well. So now this will work. If I run these applications, it will simply compile and it will run because Hilt will be able to generate the annotations. This is the manual way. We are dealing with the things. Okay, let it build. Just give a second. I guess device is booting up. I think this is a problem with everyone. Cool. Okay, so it's working, right? App में कुछ अच्छा खासा fancy नहीं है. We just want to understand the technical details. So it's able to do it. Now let's say if I comment out this whole code, okay, and if I try to run the applications, I'll run into the build failure, because Hilt will not be able to find the bindings for this, and which is yes, because we are injecting the repository into view model, right? So Hilt is not able to bind. So what we want to do is, we don't want to write the manual code. So the first things we will do is we'll define our custom annotation. Okay, so custom annotations, how do we define it? Using the annotations class. So for example, I have created one module here, and I have created one annotations as well. Okay, so the annotations is a Kotlin keyword and annotation class, generate bindings, and then we have one variable inside this class called type. What is this type? Type is actually the interface that you want to bind with this implementation class. Okay, and the data type of this type is a K class. Okay, I'm not going into class and K class, I assume you know. Basically it represents actual class instance of a class at the runtime. Cool. So our annotations will be available in a binary, and it can be applied on a class. Okay, so see, the annotation target is a class. So if you try to add these annotations on, let's say, property or functions, it won't work, because the target is class. So एक function अपन ने बनानी है, ठीक है. Second thing is, what we will do is we'll write our annotation processor. We will read wherever this annotations is applied. For example, repository में, as you can see, I have used this annotation. It's called a generate binding, and the type is my repository class. Okay, so this is implementation, and this type is the implementation that interface that I want to bind with this implementation. Cool. So far so good. Annotations are in place, and we have created a custom annotations and used it as well. Now what we will do is we will need to write a KSP processor. Okay, we'll write our own code. We'll tell the KSP that wherever this annotations is used, just tell us, and we want to do some things. Oh my god, someone is calling me. Just give me a sec. This is the okay, sorry, my bad. Okay, so we are going to create a symbol processor. Okay, so what we are going to do, uske liye we'll create another module called processors, and then inside the Java we'll write our generate binding processor. What this does, it generates the binding for us. Okay, so what we'll do is we'll take KSP has these things called a code generator and logger. If you want to, while generating the code, if you want to log some things, you can use a loggers. This is provided by the KSP, and then there is this thing called a code generator. What this class will do is, this class will generate the code for us. And all of the generators in the KSP, if you went to use a KAPT, you had to extend the annotation processor class. In case of KSP, it's a symbol processor. Okay, so once you implement the symbol processor, you need to override one method called process, override function process, and you will get the resolver. Now let's look at this line number 50. What annotations we are interested to look at is this generate binding, because this is where we applied on the repositories. So I'll just get a class instance of these annotations. Now what we'll do is, if you see the steps, we will get all the classes annotated with custom annotations, extract the target type from the type parameter, जो भी उसका इंटरफेस के साथ उसको बाइंड करना था उसको एक्सट्रैक्ट करेंगे, फिर पैकेज नेम भी निकालेंगे, बिकॉज जिस पैकेज में अपना रेपोजिटरी इंप्लीमेंटेड है उसी पैकेज में अपन बाइंडिंग्स भी लिखेंगे, बिकॉज अगर आपने if you move this to some other packages, it won't be able to find it, right? तो पैकेज भी अपन को निकालना है, and then we'll generate the module class. with the bind methods, and then we'll generate the source files using the Kotlin Poet. So Kotlin Poet is the library. This is the things we are going to do. ठीक है, तो सबसे पहले we are going to tell the KAPT that hey, give us all the classes where our annotations is used. Okay, so what we are doing is we are doing the resolver dot get symbols with annotations. Symbols means anything. It could be a class, it could be functions, it could be whatever. So we are going to get all these things where this annotations is applied. Annotation class is our generate binding class. Okay, and we only want the classes where these things is applied. Okay, so we'll filter out all the instance with a KS class declaration. These are KSP internals. I'm not going into much details, but basically we are extracting out all the symbols which is a class and where this annotations is applied. Cool. Now we'll get a list of classes. We'll iterate over it using the logger. We'll add the information that okay, we are generating the help module for this class, and then finally we'll generate the module. Okay. तो मॉड्यूल वाले क्लास में क्या लिखेंगे? We'll take the class instance. Now we will extract the generate binding annotations. तो जो क्लास अपन को KSP ने दिया उसके ऊपर से will extract all the annotations. ठीक है, it might be possible कि वो रिपोजिटरी के ऊपर और भी annotations लगे जैसे कि @singleton or whatever. We are not interested into that annotations. We are only interested into our generate binding annotations. So we will get the first annotations where the annotation name is equal to our annotation class dot name. ठीक है, तो अपना जो generate binding annotations है वो अपन ने निकाल लिया. ठीक है. And second things we will do is we want to grab the type parameter name as well. ठीक है, तो type parameter मतलब ये जो चीज है this things is we need to grab कि भाई इसकी वैल्यू क्या है. ठीक है, ये कौन सा इंटरफेस का नाम है, तो we need to grab this as well. तो we'll use annotations dot arguments. annotations अपन ने निकाल लिया ये वाला, फिर ये इसकी arguments हो गई. ठीक है, तो annotations dot arguments and then we'll filter out the name as a type. अगर आपके पास multiple properties है annotations class में तो you can grab all properties this. तो we are extracting the type argument as a KS type. ठीक है, तो KS type is a type in the KSP. ठीक है, दो चीज मिल गई, annotations भी मिल गया, type भी मिल गया. अभी क्या करेंगे? इंटरफेस का नाम निकालेंगे, इसका नाम, this one. तो this is a type. So type arguments dot declaration dot simple name. तो basically type का जो नाम है वो अपने इंटरफेस का ही नाम है, right? तो we'll grab it. We'll grab the interface name. Then we will get the implementation class name as well. My repository IMPL जो class था उसका नाम अपन यहाँ पर निकालते हैं. तीसरा, we are extracting the package, right? Because we need to place the hilt generated code into appropriate package as well. So we are grabbing the package name as well. And then we will construct our module name. hilt का जो module name अपन लिखते हैं तो interface name dot module. तो अपना जो मॉड्यूल बनेगा उसका नाम ऐसे रहेगा my repository module. ठीक है, तो we did these things. Cool. Now what we are going to do is we need to generate this binding function. सबसे पहले क्या करना है, ये जनरेट करना है, this one. That binds abstract function, bind my repositories and all these things. तो अपन को क्या करना है, अपने कोटलिन कोड से दूसरी कोटलिन की सोर्स फाइल जनरेट करनी है, राइट? और जावा whatever. तो there are two pretty popular libraries. One thing is known as a Java Poet. Okay, दोनों स्क्वायर की है. One library is a Java Poet which allows you to generate the Java source code. We'll look at these generated files as well later. Another library is called a Kotlin Poet which allows you to generate the Kotlin source file. Okay, and as you know, we are all into Kotlin. We are going to use the Kotlin Poet library. Let me just give you a glance. Yes, we are going to use a Kotlin Poet library. pom.squareup and Kotlin Poet and Kotlin Poet. Cool. ठीक है. So now what we need to do is we need to generate the bind function. Bind is a function, right? So we will use a function specification class function spec.builder. फंक्शंस का नाम क्या रहेगा वो बिल्डर में देंगे, तो वी विल जस्ट यूज अ बाइंड एंड देन इंटरफेस नेम, बिकॉज इफ यू सी द मॉड्यूल, sorry, just give me a second. Yes, if you see the module, functions का नाम था bind interface name, ठीक है, bind and then interface name. So we are creating a function called a bind interface name. Then we want to make this class as abstract, okay, because if you use a bind annotations you need to make your class abstract. So we are going to add a modifier called kmodifier.abstract, ठीक है. Second thing is we need to add annotations on this class, तो sorry on this function. तो ये जो function था उसके ऊपर binds annotations we want to add, right? So we add using the add annotation method. Then this function is taking one parameter called implementation, sorry, IMPL, and this is the type of it. So we'll add the parameter as well. So IMPL and the type is implementation class.class name, ठीक है. And these functions returns this class, sorry, this interface. तो वो अपन यहाँ से रिटर्न करवा देंगे, then we'll call the build, okay. So far what we did is we wrote a code that will generate the bind functions for us, okay. Now we'll deal with the rest of the things as well. Cool. So this bind का सीन खत्म हो गया, अभी ऊपर वाला सीन बाकी है. abstract class ये, उसके ऊपर एक install in component and then module, ठीक है. तो अभी जनरेट करेंगे मॉड्यूल क्लास. You could generate a class or you could generate a object as well. So we will use a type specification and then we want to build a class. So we will use a class builder, okay. फिर मॉड्यूल नेम दे देंगे जो भी अपन ने ऊपर रिट्रीव किया. Then if you want to add some documentation, then you can do as well. So if you can use add kdoc method. What this will do is just like we have a kdoc, right? Just like a Java doc, we have a kdoc for Kotlin. ठीक है. So this is the documentation. We want to make this class as abstract because this class is abstract. And on top of this class, we want to add this annotation. We want to add this annotation called a module. So we are adding this module. Another annotations we need to add is this install in. Now this is not a normal annotation. This annotation takes the parameter as well. तो ये जो install in है वो एक components type का class भी ले रहा है कि भाई कौन से components पे मुझे add करना है, ठीक है. तो अपना generation logic भी ऐसे बन जाएगा. Install in class add करेंगे, उसमें एक member डालेंगे, that is your component. So you can have singleton components, you can view model components and whatever you want. So now this is hard coded in this use case, singleton component. But what you can do is in your annotations you can also take this as a parameter. तो users के पास flexibility रहेगी कि उनको कौन से component में install करना है, ठीक है. And then you can retrieve and use it. Now inside this class, ये class के अंदर ये function अपन को add करना है. तो ये class बन गया, उसके अंदर अपन ने जो previous functions bind functions generate किया था, this is something we will add, okay, using the add functions dot build. So अपना class generation वाला काम खत्म हो गया, ठीक है. Now what we want to do is now whatever the code we have generated, we need to write somewhere. We need to create a new file, okay. So build can find it. So we are going to use a file spec.builder. ये package name पे file रखेंगे, module name ये रहेगा, मतलब file name रहेगा module name. Then we are going to add this type. That means ये जो है वो file का content, ठीक है. ये file बन गई इस package पे ये नाम से, and this is the content and this is the build. Now we will write this file using the code generator. कौन दे रहा है code generator? KSP. KSP को बोलेंगे कि जो भी अपन ने code generate किया है उससे एक new file बना and this is your content. There is no dependencies, so we are not dealing with that things. Now KSP should be able to generate the source code for us, okay. Now one thing is how KSP will be able to bind this, how KSP will understand कि ठीक है I need to use this generate binding processor, right. So we need to go and tell the KSP as well. How do you do it? You create a symbol process provider, okay. So you create a class which just simply extend the symbol process provider and you override the onCreate method. यहाँ पर आपका जो actual processor है that you need to write. We in this case we are using generate binding processor and code generator we are getting from again KSP environment.code generator and logger is from the KSP. तो ये अपन ने KSP को बोल दिया कि ठीक है, this is a provider, this class will provide my processor. Now what you need to do is in order for the KSP to find this class itself, okay, you need to create a new directory called a resource and then meta inf then services, and यहाँ पर exactly ये नाम से com.google.devtools.ksp.processing.symbol process provider, this is hard coded. You need to give a file this name and उसके अंदर आपका जो प्रोसेसर प्रोवाइडर है उसका पूरा पाथ देना है, ठीक है. तो वो अपन ने दे दिया पाथ ताकि KSP can look at these things. Okay, cool. So this is done. So this is a manual process. There are other ways. For example, if you are dealing with a KAPT, there is this awesome library from the Google called Auto Service. किसी ने नाम सुना है Auto Service का? Google has these things. Give me a second. Google Auto Service. So what this class is do is basically it can generate the files in the meta.inf directory. तो आपको नहीं करना पड़ता, ये library करते थे, ठीक है. Now this won't work with the KSP. So there is another library from Jack Swears called Auto Service KSP. If you want to use these things, if you want to do the manual work, भाई ये क्या आ गया? ठीक है. So jackswears.autoservice KSP. So you can use this library as well, and this will do this generate and stuff, this meta inf stuff for you. But let's go manual. I mean it looks odd कि automation की session में we are going manually, but ठीक है. So this is the manual process. Now KSP should be able to find this thing. Okay. Now what we are going to do is our code resides in the app module. ठीक है. Annotations resides in the annotations module and processor resides into the processor module. Okay. तो app के अंदर in order to access the annotations we need to add the dependency called implementation, and this module is a part of a project, so we'll just use @project. ठीक है. Now what we need to do is this annotation processor module is a KSP module. Okay. तो we need to uncomment this line as well. ठीक है. ये syntax आपने देखी होगी KSP and then you would use whatever, room का हो गया या तो retrofit का हो गया या जिसका भी हो गया. अपने केस में ये अपना कस्टम प्रोसेसर है, ठीक है. तो it's a part of a project, this module is a part of a project. तो मैं ऐसे लिख रहा हूँ, if it would be coming from let's say Maven Centrals or somewhere like this, तो I'll just define the dependency name. So this is a KSP processor. ठीक है. Now what we can do is we can use this repository. Yes, we can use the generate binding annotations. We can give it a type. If I try to run the applications, hilt वाला देख लो commented out है, ठीक है. तो now if I run this application, let's see what happens. Awesome, app is running, right? So someone generated this sort of code for me instead of me writing this everywhere. Right. So let's see where it is. So if you go, this is a generated code, right? So generated, one thing to note is generated code is accessible at a runtime. ठीक है. तो यहाँ पर भले ही आपको ना दिखे, but it's accessible at a runtime. तो जो भी library is looking for it, they will be able to find it. So you go to your application because this is where we are generating code. ठीक है. I'll need to switch to project mode because Android mode won't show me this. तो ऐप के अंदर go to build because this is generated code and this will be invalidated on each changes. ठीक है. इसके अंदर build and then generated के अंदर we are using KSP. So KSP उसके अंदर this is a debug build, so let's just use it. We are generating a Kotlin source. Okay, if it would be a Java, you find it in a Java and now this is a Kotlin. इसके अंदर ये मेरा पैकेज नेम हो गया and then there is this generated file. ठीक है. ये देखो ये पूरा का पूरा उसने जनरेट कर दिया and ये जो KDoc में हो रहा था ना वो भी उसने डाल दिया hilt module for binding this repository. तो उसने क्लास पब्लिक एब्स्ट्रैक्ट क्लास बना दिया, रिपोजिटरी मॉड्यूल बाइंड्स डाल दिया, उसके अंदर मॉड्यूल एंड इंस्टॉलिंग एनोटेशंस भी डाल दिए। तो नाउ व्हेन द हिल्ट विल लुक फॉर दिस कि ठीक है इस रिपोजिटरी का इंप्लीमेंटेशन का बाइंडिंग किधर है, ओके। सो हिल्ट विल बी एबल टू फाइंड दिस क्लास, दिस मॉड्यूल, एंड हिल्ट विल यूज दिस। सो हिल्ट नोस कि ठीक है ये रिपोजिटरी इस इंप्लीमेंटेशन के साथ बाइंड की हुई है, ठीक है। तो हिल्ट विल रन विदाउट एनी इश्यू। So this is how you write your own annotation processor. Okay, cool. Any questions, any things on this part? I just have a few and one more things to cover, and then we can wrap up. But any questions up to this point?
Yeah.
Yes, please.
So what decides the ordering of this? So how do you know that your code is generated before Hilt is going to read it?
So this generation of this code runs at the compile time. So whenever your applications is getting compiled, the code will be generated. Okay, and it will be generated and then it will be placed into your आपकी applications के जो भी classes along with it. So when the Hilt reads it, the Hilt should be able to find these things. So all these things generation happens at the compilation time. Cool. Any more questions? Anyone? Yes, please.
So if we are writing this model, and at what point we should consider creating our own custom annotation?
Okay, at what point? So you need to consider, or you should consider having your custom annotations is whenever you feel that things are boring and things can be automated. ठीक है, ये हिल्ट वाला जो केस था वो मैन्युअली अगर आप लिखते तो इट्स अ बोरिंग एंड लेबरस टास्क, करना नहीं है हमको। तो व्हाटएवर द थिंग्स कैन बी ऑटोमेटेड, वी बेसिकली डू होल लॉट ऑफ ऑटोमेशंस, उस पे भी मैं भी थोड़ा आता हूं। तो whenever you can see कि things can be automated, you should consider using the annotation processes.
But this adds overtime, runtime overhead.
No, there is no runtime because this whole process is a compile time process. So runtime पे there is no overhead at all. It's just this class are created at compilation time.
Rajesh, can you show? I didn't get like how we consume that annotation.
Okay. So basically, wherever you have defined your annotation, for example, let's say into this module or whatever module, you add this module as a dependency. Wherever you want to use it. For example, app में मुझे use करना है, तो I'll just add this module as an implementation, and then I'll just simply call this generated binding. It's coming from this, and I'll give it a type कि I want to bind this class with this interface.
Okay, so directly source code only we are annotating.
हाँ, source code annotation सी जहाँ पर wherever you are adding the annotations, it's in the source code only. The generation will happen by the KAPT. Okay. Anything else? Cool. So one more things to cover is I think it's related to the questions this guy asked me. When should we consider this? So the answer is wherever you feel that things can be automated, you should use these things. For example, let's say this is what we do at my organizations, but I'm not doing it because I need to do a whole lot of things. So let's say assume that you have a data class called a person, okay, which has IDs and values and all these things. Now there are two types of classes, 2, 3 and classes, a regular person and special persons. What you are doing is you need this both properties, ID and name. इसमें चाहिए, इसमें भी ये दोनों properties चाहिए, बस उसके साथ अलग भी properties चाहिए. But basically what you want is you want to reuse the properties, okay? मान लो आपका server is returning a JSON and काफी सारे instances जहाँ पर same properties are being used. तो अगर same properties हर जगह लिखने बैठोगे तो it's a duplication. ये सारी चीज जो अपन करते हैं, ठीक है, ये डालते हैं, तो this is a duplication. Duplications can be automated. क्या करना होगा उसके लिए? एक annotations class बनाओ, let's say annotation class compose, ठीक है, फिर ये जो annotations है वो यहाँ पर लगा दिया कि ठीक है, this class is composed. Composed means what? Wherever this person class is used, उसकी दोनों प्रॉपर्टी लेके अपन यहाँ पर एक्सपांड करेंगे, ठीक है? तो उसकी दोनों प्रॉपर्टी यहाँ पर एक्सपांड करेंगे तो रन टाइम पे ये क्लास बन जाएगा वेल आईडी वेल नेम, ये क्लास बन जाएगा वेल आईडी वेल नेम एंड वेल स्पेशल. ओके, दिस इज द यूज केस. एंड ये काफी बार आई गेस काफी लोगों ने फेस किया होगा कि मेनी प्रॉपर्टीज वी आर रीयूजिंग इट. ठीक है, फिर क्या करना पड़ेगा? देन यू नीड टू राइट योर ओन एनोटेशन प्रोसेसर व्हिच प्रोसेस दिस कंपोज्ड एनोटेशन. ठीक है, वो प्रोसेसर कंपोज एनोटेशन रीड करेगा, उसकी प्रॉपर्टीज निकालेगा इस क्लास के अंदर जाके, 2 3 जितनी भी है सब निकालेगा. एंड नाउ अभी क्या होगा? अभी सिर्फ एनोटेशन प्रोसेसर लिखने से काम नहीं चलेगा, क्योंकि इस क्लास का लेट्स से इफ इट्स यूज्ड फॉर जेसन पार्सिंग, इसका अडेप्टर तो योर लाइब्रेरी बनाएगी. तो मान लो मोशी है, जीसन है या कोटलिन का है, वो लाइब्रेरी इसका अडेप्टर बनाएगी. तो वो एडेप्टर भी आपको जाके कस्टमाइज करना पड़ेगा. इफ यू यूज अ मोशी डायरेक्टली एज अ लाइब्रेरी, तो मोशी की कितने लोगों ने यूज करी है मोशी? सो व्हाट द रेस्ट ऑफ folks are doing? JSON? Just a weird man. JSON is in maintenance mode as well, by the way. Cool. So मोशी या JSON जो भी है उसका पार्सर लिखना पड़ेगा. एंड उसको अगर इफ यू यूज these things as a library, you won't be able to do it because it's internal. तो हम क्या करते हैं, मोशी का जो पूरा का पूरा सोर्स कोड है उसको हमने उठा लिया एंड देन जो भी चीज है हमें कस्टमाइज करनी है, जैसे कि एडेप्टर जनरेशन लॉजिक, ठीक है, तो उसको कस्टमाइज करेंगे, उस पे देखेंगे तो दोनों से साथ साथ में चलेगी, एनोटेशन प्रोसेसिंग प्लस उसका कस्टम अडेप्टर. अडेप्टर में we will see in the adapter generation code what we will see is we'll retrieve these things, प्रॉपर्टीज लेंगे एंड फिर उसका जो अडेप्टर जनरेशन लॉजिक है उसमें इसको एक्सपांड कर देंगे. ठीक है, तो मोशी को जो क्लास फाइनली मिलेगा उसमें दिस प्रॉपर्टीज विल बी एक्सपांडेड, तो आपका serializations will properly work. Okay, so the essence is whenever you want to automate the things or whenever you think it's a laborious, write these kinds of code, तो आपका काफी सारा टाइम बच जाएगा. One more important point to note is annotation processes can only generate the code. They cannot modify the existing code or they cannot replace or delete or basically whatever. For this use case, you will need to build a compiler plugins. Compiler plugins are way harder than annotation processes because the compiler API is a private. तो उसका कोई documentation नहीं मिलेगा. On this topic, last session में मैंने I think यही पर talk दिया था. So I'll share the link on after this session, see how to build your own compiler plugins as well after the session ends. So ठीक है, I think that's all I wanted to cover. Any questions, anything? Yes please. This guy asked in compiler plugin session as well. Yes.
So I'm not sure if I'm missing anything here, but
Okay.
won't this make debugging the code a lot harder?
Won't it make the debugging code lot harder? Yeah, makes sense. I mean, this use case only or the previous one?
This use case.
This one.
Might be some other use cases.
Okay, cool. So basically, debugging. We by the word debugging we usually do when your application is running, right? So both of these things, annotation processing and compiler plugins, happens at the compilation level. ठीक है, तो आपका build ही फट जाएगा. ठीक है, if there is an issue at all, आपका build ही फट जाएगा. You won't be able to compile it properly. And compilation में तो compiler gives you warnings कि भाई ठीक है कहाँ पर फट रहा है, क्या फट रहा है, तो you can just go and have a look. तो ऐसा नहीं होगा कि मैंने कुछ गलत छाप दिया यहाँ पर तो रन टाइम पे मेरे यूजर्स को क्रैश फील हो रहा है and they are bombarded कि एकदम घटिया एप्लीकेशन है, ऐसा तो I guess नहीं होगा, क्योंकि this is a whole compilation process. तो आपको build करते टाइम you will get the idea कि what is wrong. Okay, cool. Anyone else? Sorted. Cool. I think that's all. And one more thing. These are some references. Few things. All these slides that whatever the speakers we have, all these slides, yes, slides in repos and all these things. वो आपको अवेलेबल हो जाएगा, अपना जो ग्रुप है, व्हाट्सएप ग्रुप है, उसमें we'll add it. So don't worry, don't be in a rush. We'll send all these things, photos and all these things. Cool. I think that's all. Then I think it's all, and it's 1 p.m. as well, so it's food time. I assume Gaurav is ready with the food as well. Cool. Cool. Thank you. Yep. Have a good day.